So scalar. Energy is scalar. Energy dimension is ml squared T minus 2. Kinetic energy is half mv squared. Then we have potential energy, PE, mgh. And then we have so many forms of energy. We're not going to start writing them now. Renewable energy, world energy resources. World energy resources. World energy resources. We have two of them. We have the renewable and the non-renewable. This is very important. Synoptic form. Renewable. We have non-renewable. Renewable and non-renewable. For renewable, we have solar. We have hydro. And of course, we have wind. These are the one we have. For non-renewable, we have nuclear. We have coal. And then we have the biomass. Biomass, that's what we have. And then we have power. Power is rate of doing work. Rate of doing work, that's power. Rate of doing work. Then power is, can just say FV. Can say work done over time. Work done over time. And then the dimension is ml squared T minus 3. Power is scalar. Power is scalar. It's not work. So these are the three things we need to know. Work done, we have FD cos theta for work done. Work done is scalar. Unit is joule. Dimension is ml squared T minus 2. Daniel and Michael, please, I expect the classes to have a screen on my side here. We should do that. We remove the screen from the and put screen. By this right-hand side here, there should be a screen here. What happened in the engineering class? No screen. It's shaking. Daniel, where is Daniel? Where is Michael? Michael. Where is Daniel? None of them is in the office. I don't know why it's taking you time for you people to listen, to answer me when I'm calling you. It takes time. The engineering students are coming to the top floor. They said their screens are not working. All of them are here. So I don't know what is happening. That's what they told me. Anyway, once we have a space to sit down, there's no need to start going up and down. Once there's space here, you can sit down. Come and put all these bags down. Just sit down. Sit down. Any bag you see in the class, just put them on the floor and sit. There's no biology today, so you can decide to stay here. No problem. We are still going to have revision in the afternoon from 1 to almost 5. Just come in, put the bags, all the bags on the floor. Anybody who is not in class now, maybe they have gone to the admin office. They ought to have done that since before now. So replace them. This side, please, all of you, put all the bags on the floor. That's the instruction I've given you now. The admin came to the office yesterday to even attend to people so that they can have their receipt this morning, before this morning. So just sit down, remove the bag. When they come, let them go and sit at the back or ground floor. Michael, I want a screen by my right-hand side here at the top floor. I want a screen. Whether the screen there is faulty does not mean we cannot replace it. Let's replace it. Let's try question 1 now. We don't have time. We have many topics to do. Right, calculate the work done. Calculate the work done. Calculate the work done on the body in the figure below. Calculate the work done on the body in the figure below. If the body was displayed by 4 meters. If the body was displayed by 4 meters. if the body was displaced by 4 meters, if the body was displaced by 4 meters, if the body was displaced by 4 meters. So that's the first formula that you expect to know how to use, the formula for work done. So solution, work done is always FD cos theta. We've done that several times. We've solved an equation like that before, FD cos theta. And our first line is 200. The distance is 4. And then we have cos 60. They always like to give you cos 60 because they know that cos 60 is half. So that's like 400 joules. So work done is always FD cos theta. That's work done. FD cos theta. We're on 2. We're on 2. A stone of mass, we have to write very fast. This is revision class. It's not time for writing sluggishly. A stone of mass, 20 grams is released. A stone of mass 20 grams is released. A stone of mass 20 grams is released from a catapult. From a catapult whose rubber, a stone of mass 20 grams is released from a catapult whose rubber is stretched. Whose rubber is stretched through 5 centimeters. A stone of mass 20 grams is released from a catapult whose rubber is stretched through 5 centimeters. Through 5 centimeters. Full stop. If the force constant of the rubber, if the force constant of the rubber, if the force constant of the rubber, if the force constant of the rubber is 200 Newton per meter, if the force constant of the rubber is 200 Newton per meter, 200 Newton per meter, comma, calculate the speed with which the stone, calculate the speed with which the stone leaves the catapult. Calculate the speed with which the stone leaves the catapult. Calculate the speed with which the stone leaves the catapult. The speed with which the stone leaves the catapult. The speed with which the stone leaves the catapult. Now, when you're solving questions in science, especially physics, you are expected to sometimes write out the data. Data will help you. Yeah, let's go. Read the question for me. Let me hear. Don't forget to convert that one immediately. 20 over 1,000 kilogram. That will give us 0.02 kg. Yeah, go on. Yes. Yes. That's our extension. 5 centimeters. That 5 centimeters is 0.05 meters. Yes, go on. That's our K, force constant. Yes, how much? 200 Newton per. Yes, go on. Speed, V. Now, potential energy is the energy that is stored in a body. And there are various types of potential energy. We have the gravitational potential energy. We also have the word elastic potential energy. Now, the one that you have in a wire, in a catapult, when you stretch it, that's elastic because it's being stretched. But we're going to revise that today, elasticity. So when you stretch a body like that, the energy there is elastic potential energy. But when the stone now begins to move, class, what is the energy possessed by a moving body? Kinetic energy. So you're going to have elastic potential energy is converted to kinetic energy. So we have EPE, we don't have time. EPE equals KE. When you are stretching a catapult or you are stretching a spring, the energy in that body is called elastic potential energy. EPE, and then we have KE. And the formula is half KE squared. We still do that when we come to elasticity later today. So we have half mv squared. That's it. K is half mv squared. So from there, half cancel half. You know. So half K. What's your K? How much is K? 200. What's our extension? 0.05 all squared. What's the mass? 0.02 v squared. Who has calculator? What is 200 times 0.05 squared? We don't have time. 0.5, thank you. Equals 0.02 v squared. Then our v squared will now be what? 0.5 over 0.02. What do you get? 25, thank you. Our velocity will now be square root of, so what's the answer now? 5 meters per second. 5. Let's go question 3. A 70-kilogram man, are you true? So we have elastic potential energy equals the final kinetic energy. So now we can also have energy being converted within two potentials. For example, I have a ball high up here. Before I drop it, the ball has gravitational potential. So why? Well, it has height, mgh. When I drop that body, for example, on a spring, what will happen? By the time it falls on the spring, it will compress the spring. So that energy of compression is also elastic potential energy. So you can have potential. You can have a gravitational potential dealing with height, combined to that. There was a question we saw some, months back when a body was put on a spring, and then they allowed the spring to push the body up. So initially, when they press it down, that's elastic potential. When it goes high up to the sky, at the maximum height, it has only potential, which is gravitational. Let's go. Question 3 now, quickly. A 70-kilogram man ascends a flight. A 70-kilogram man ascends a flight of stairs. A 70-kilogram man, please, at the back of that door is a knob for the fan, the switch. Help us when it's close to the door there. A 70-kilogram man ascends a flight of stairs of height 4 meters. Of height 4 meters in 7 seconds. Of height 4 meters in 7 seconds. Of height 4 meters in 7 seconds. Full stop. Find the power expended by the man. Find the power expended by the man. Find the power expended by the man. Classwork. Everybody should do that. That one shouldn't take more than 10 seconds. Don't forget power. Power expended by the man. Are we true? Very good. Power. Claire, what's the formula for power? mgh over time. Work done over time. How much? What's the mass they gave us? 70. What of gravity? What of height? What's the time? So what's the answer now? 400 watts. Let's go. Next question now. Number 4. The force and displacement vector. The force and displacement vector. The force and displacement vector are given as. The force and displacement vector are given as. The force and displacement vector are given as F equals 3I. I don't know where this is coming from, but let's just do any form of division. Plus 2J and D equals 7I minus J. Yeah, in revision, we do all kinds of things. Anywhere jam is coming from, you will destroy the question. Find the work done. Find the work done. Don't say, sir, you've not taught us before. That's why we are doing revision. In CPT, sometimes in CPT, you see some strange question, maybe one or two. We are ready. So, want to find work done. I gave it today. Some of you have done vector before. Work done is scalar. I'm going to scalar. You have to be what we call the scalar products. You know, so work done is force. Work done is F dot D. That's it. We call it scalar products. You know, and in scalar products definition, F dot D is called FD cos theta. FD cos theta, which we have written. So what you just do is that you write all the force together, 3I plus 2J, and then dots, then D, 7I minus J. Now, how do you find dot product? Dots multiply, you multiply the I with I, J with J, that's all. And then you add your answer. So let's go now. 3 times 7, what's 3 times 7? Don't say 21I squared though, 21. Then this one, what is, there is minus 1 here, do you know? Minus 1. What is 2 times minus 1? So what's the answer? 19 joules, that's all. I'm sure if they bring this one, you will smile in the exam. You multiply the first I together, 21, and this one together, minus 2. And then 21 minus 2, 19. And what you may see again is that which of the following is the derivation of work done? Don't forget F dot D. So don't say it's not complete. Don't say they didn't put cos theta, no, F dot D. We move. Next question. Number what? Number 5. An engine of a car. An engine of a car. An engine of a car of power. An engine of a car of power. Of power 2 kilowatts. 2 kilowatts. Moves on a rough road. 2 kilowatts. Moves on a rough road. With a velocity of 25 meters per second. With a velocity of 25 meters per second. With a velocity of 25 meters per second. Full stop. Calculate the force required. Calculate the force required to bring it to rest. Calculate the force required to bring it to rest. Calculate the force required to bring it to rest. Calculate the force required to bring it to rest. The force required to bring it to rest. Required to bring it to rest. Look at that. I'm sure you can do that. Power, the last formula we wrote on power, work done over time, power is also FV. That's it. So look at power. Power is work done over time. Work done over time. So what is power again? Power is force times distance over time. Let me put it this way. Force times distance over time. So we now separate them. You're going to have power is force times D over T. And now say power is F times V. That's it. So another interesting formula is power is FV. It's in our note already. FV. Force times velocity. How much power are we giving in the question? Check. How much power? That's 2,000 watts. Abi now. Don't forget to convert. What's force? Unknown. How much velocity do we have? 25. So our F now will be 2,000 all over 25. What's the answer? 80 Newton. That's it. 80 Newton. Power is FV. Force times velocity. 80 Newton. 80 Newton. 80 Newton. Now, let's go. Number what now? Number 6. Which of the following graph give the correct relationship? Which of the following graph give the correct relationship? Which of the following graph give the correct relationship between energy and mass? Between energy and mass. Between energy and mass. Between energy and mass. When mass is converted to energy. 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 So we're going to have 4 different graphs. So just catch them. Then we pick one. When mass, that's a very interesting question. I'm not sure you've seen that before. When mass is converted to energy. So we have energy and mass. Energy here, we have mass. Here, we have energy and mass. Energy. We also have mass here. The first one is a straight line through the origin. Second one is like this. This is A. This is B. Then this is C. Energy and mass. And one this way. And there's not D here. Energy and mass. Energy, mass. This one went down. Look at that. So we have this kind of relationship.
Energy is first existed.
Energy and mass. You know, this relation. So you have to know that everything we are doing now is very important. These are called likely questions. AOC, area of concentration. Did anybody know relation between energy and mass? When energy is converted to, when mass is converted to energy? You want to try. Is there anybody that wants to give me mathematical relation between energy and mass? When mass is converted to energy? Anyone? Who is raising hand? Yes. E equals mc squared. That's correct. That's 1,000 for you. Energy. When mass converted to energy, that's delta mc squared. Your thoughts? That's it. Energy is converted to mass. Delta mc squared. And even if you go to all the formula for energy, that's how nuclear energy is converted to mass. Let me say that they give us, okay, energy and mass. So energy is delta mc squared. Class, who can now tell me, now what's the relation between energy and mass in that equation? I can't tell you. Direct. So the answer is A. You know, so get the formula fair before you pick it. If it's energy and velocity, it can't be A again because velocity is having power 2. You know, it will still be direct. That one can be this one. You know, so we have delta mc squared. That's nuclear energy. That's the formula that tells you how mass is converted to energy. So, congratulations, boy. A new month's money. What are you doing in the middle floor today? See how favor works. I know your class is ground floor. You'll have lost 1K now. Yeah, we'll move. Many of you still want more money this month. I want to give a lot of money out this month. It's the final month for JAM, so a lot of AWOF everywhere. Yeah. Okay. Let's go. Next question. Number what now? Number 7. Find the potential energy of an object. Find the potential energy of an object of mass 10 kilogram. Find the potential energy of an object of mass 10 kilogram. Let's show you for this floor. Have we spoiled all this fan? These two are not working. They've not been working, have we? Eh? The switch, okay. Oh yeah. Find the words of an object of mass 10 kilogram placed on a building. Placed on a building floor. Placed on a building floor, 10 meters. 10 meters above the ground level. 10 meters above the ground level. 10 meters above the ground level. Quickly, do it. I'm sure you all know the formula for. Have you gotten your answer? Very good. Potential energy is mg what now? Mgh. How much mass are we given? 10. What's gravity? Height. So the answer is what? 1,000 joules. Let's go. Next question. Number what? Number 8. When the speed of a car is halved. When the speed of a car is halved. When the speed of a car is halved. Come on. When the speed of a car is halved. Come on. Its kinetic energy is. Its kinetic energy is. Yeah. Option A. Doubled. 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 Option B. Halved. Halved. Option C. Quartered. Quartered. Option D. Quadruple. Quadruple. Classwork, yeah, do it. Quadruple. You are true, Abby? Class, what level of kinetic energy? Kinetic energy is what? Half m. So what happened? What do you say happened? When the velocity is halved. Class, the first thing to know is relation between Ke and velocity. Because that kinetic energy is proportional to v squared. Forget about the mass. Mass is constant. You know, so when the velocity is halved, means that kinetic energy will be what? Will be quartered. That's the answer, not quadruple. Because we are directly proportional. What does that mean? If you increase me, I will also increase. Direct. If you reduce me, I will also be reduced. But by a factor 2. Square of 2. So if this one is doubled, look at the word. If this is doubled, this will be quadruple. The square of double is quadruple multiplied by 4. If this one is halved, this one will be what now? Quartered. So the answer is what, class? Quartered. Don't just cram answer. Why, sir? Direct relationship. Had it been an answer in the question, let's say something like this. J is now m over v squared. Look at this one. J m over v squared. That means this is now what, class? Inverse relationship. So when v is now doubled, what the number to this one? Quartered. Inverse. As they sweet us, it pain them. As you are being doubled and being reduced. If you are increasing, you may they reduce. If you are reducing, you may they increase. That's inverse relationship. Inverse. So when you double this one, this will be quartered. When you have this one, this will be quadruple. That's the meaning. That's the inverse square law you were taught. When the distance between two bodies is doubled, the force of attraction or repulsion between them will be reduced by factor 4. When it is tripled, force will be reduced by factor 9. Like that. If anything is not clear like that, what do you do now? Revision. You are staring. Don't make sure you meet somebody around you. This is not the time we want to be pretending. No. Let's go. Number what now? Number 9. Calculate the work done. Calculate the work done on the body during the first 20 meters of motion. Only the work done on the body during the first 20 meters of motion. Work done on the body during the first 20 meters of motion. During the first 20 meters of motion. Sketch. Is force in Newton. Displacement in meter. Some of the engineering students who are here now, or some of us who attend class in the middle floor, and you are here now, how we didn't leave your bag downstairs with phone and money? Why so? So the question says during the first 20 meters of motion. If we go back to your notes, you see that we said that work done is what? Area under the first distance graph. That's work done. Area under first distance graph. Area under first distance graph is work done. So work done. It was area under first distance graph. Distance graph. That's work done. Area under the graph. You know? And because the graph is a what? See, it's the first 20 meters. Not everything. So that means the graph we're looking for is place. Yeah. First 20 meters. Not everything. So I can even, the graph can be divided into two sections. So I say this one. I bet this place, A, from here to here, you are rectangle. And then you are trapezium. You know, this place here. So let me find the area of this rectangle. What's the area of a rectangle? Length times breadth. Another one, half into A plus B, bracket. That's it. The first one is a rectangle. Area is length and breadth. The other one is a trapezium. Half into A plus B, bracket H. What's our length? From here to here is 50. 50. From here to here, 50. Our breadth from here to here, 10. 10. And then you have half. This one here is a trapezium. Trapezium. So from here to here, now 50. Plus from here to here, now waiting, 25. Can see it here, 25. Again, from here to here, 50. Parallel sides, from here to here, 25. And the distance between the two parallel lines is from here to here, 10. So I have 10. Again, sir, I partition the graph into two. This one here is a rectangle. Area is length, 50 times breadth, 10. This is a trapezium. So can I do my own into three? No problem. This one, then this one here rectangle, then this one here triangle. You know that it takes some little time, but you still get it. So 50 times 10 is what? 500. 2 here, 1 here, 5. This and this one is 75, Abby, into 5. So that'll be 500 plus what? 375. So what's the answer? 375 joules. Let's do the last question on motion, Martin. Content. Which of the following devices transforms light energy? Which of the following devices transforms light energy? Which of the following devices transforms light energy to electrical energy? Light energy to electrical energy. Light energy to electrical energy. Light energy to electrical energy. Option A, bulb. B-U-L-B. Option B, television. Television. Option C, solar cell. Solar cell. Solar cell. Option D, light emitting diode. Light emitting diode. That's LED in brackets. Light emitting diode. Light emitting diode. Look at that. They say convert energy from what to what? Light to electrical. You know, light follow me. Ping, like this. Current on the flow. Class, what's the answer? Solar cell. Ladies and gentlemen, we've ended that topic. We move to topic 7. Friction. Friction. Now we have friction. There's a force that opposes motion. There's a force that opposes motion. No story. Opposes motion. We also call it resistance to motion. Resistance to motion. That friction. Let's look at solid friction characteristics. Solid friction characteristics. Characteristics. These are the places to go towards the exam time. 1, increases with weights. Increases with weights. Increase with weight / normal reaction. Increase with weight / normal reaction. Number 2, opposes motion. I know you have this before, but sometimes when you have it in a simpler way, it's easier to read. Number 3, independent on area. Independent on area. Number 4, depends on nature of surface. Depends on nature. N-A-T-U-R-E. Nature of surface. Depends on nature of surface. Under major one, mu x for solid greater than mu k for friction. And then we know that F is always mu mg. Then force minus friction is always ma. Then also for inclined plane, mu 1/tan theta. 1/tan theta. Smooth surface. For smooth surface, mu equals 0. I mean, it's frictionless. Can I even say tan theta directly so that we don't waste time? We don't prove what is not tan theta. Mu. Also, mu is v squared over rg. Reducing friction. Number 1, lubrication is one of the major methods. Using lubricants, lubrication, we have a banking of sideways banking, we have streamlining, streamlining. We also have a use of ball bearing, and of course the last one, use of rollers. That's very popular. If we are traveling, you have rollers is being used to move stuff from one place to the other. Liquid friction. Liquid friction is called viscosity. viscosity. We also have Stokes law. Stokes law, friction is proportional to AV. Friction is 6 pi AV. Coefficient of viscosity. Coefficient of viscosity. Dimension is very important to us in physics. ML minus 1, T minus 1. Acceleration stage. Weights minus upthrust minus viscous force is MA. The equilibrium stage. Equilibrium stage. W equals U plus V. So that's all about friction. I'm sure we also remember the use of friction. Can use friction for sharpening of knives. Can use friction. If there's no friction, you can't walk around very easily. Can use friction in generating heat. Many use of friction. Safety belts. So another application of friction. Two examples, we will revise more on that. So let's get ready for the first question. Right fast. Let's go. Question 1. A motorcycle of mass 20 kg. A motorcycle of mass 20 kg moves round in a circle. Moves round in a circle. Moves round in a circle of radius 8 meters. Moves round in a circle of radius 8 meters with a velocity 8 meter with a velocity of 4 meters per second. Velocity of 4 meters per second. Full stop. Find the coefficient of friction. Find the coefficient of friction between the road and the tire. Find the coefficient of friction between the road and the tire. Find the coefficient of friction between the road and the tire. Between the road and the tire. Now, we should not forget that friction opposes motion. And friction makes life difficult for you, especially at the beach, where the surface is rough. You cannot walk very fast. You are walking, you are, gasping for air, panting and all that, because you are going to expend a lot of energy in the surface. So, let's leave that for now. You see some tires, you have watched Formula One before, when they are trying to bend like this. Have you even gone to Intersport before? They invite me as guest, Adam's house in some schools. And I will go there. And I'll be seeing Ojoro when they are doing racing. So when they want to race like this, they put line. This is track like that. Then when they are, after they have maybe 400 meters, after they have done the 200 meters, they want to bend around the corner. Somebody else go like, damn. Can you see? But there's no line there. Sometimes they will use tire. They put some tire and the guy just I said, go and stop that guy, you stop him. You know. So because number one, even if you don't want to cross like this, there's a tendency for your body to slide like that. That's why in Formula One, you see many cars, when they are skipping, some of them will even eat themselves around there. You know. So that force that always bring about that frictional force is that one there, mu. So how do you get that formula there? We got it from the fact that centripetal force is the force that bends towards a curve. You just say centripetal force equals what? Frictional force. Because in case you forget the formula in the exam, centripetal force equals what, everybody? Frictional force. At that curved surface, you have a frictional force. Who remember the formula for centripetal force? Very good. What are our frictional force? Mu mg. We wrote it today. Mu mg. Mu mg. M can cancel m. So this thing will now go down. Or you will cross and apply. Rock will now be v squared. So our mu, what will it be, everybody? V squared. And so don't forget the formula. V squared over rg. So in case you forget, derive it yourself. Let's go. We have given what velocity they give us? 4 squared. Radius in call 8 times 10. So that'll be 16 over 80. Abi now, what's the answer? 0.2. Mu no get units. Very easy. 0.2. 0.2. Up no. So the answer is 0.2. Question 2, shall we? A 500 Newton box rests on a horizontal floor. A 500 Newton box rests on a horizontal floor. A 500 Newton box rests on a horizontal floor. Full stop. A constant horizontal force is exerted on the box. A constant horizontal force is exerted. A constant horizontal force is exerted on the box so that it moves through 8 meters. So that it moves through 8 meters. So that it moves through 8 meters. Full stop. If the coefficient of kinetic friction, between the floor and the box, if the coefficient of kinetic friction between the floor and the box is 0.22, between the force and the box, between the floor and the box is 0.22. Where's Uncle Michael? Is he around? 0.22. Come on. Calculate the work done on the box. The work done on the box. Work done on the box. Did they apply force on the question? How much force? Are you sure that's what they said? Read the question. 500 watts. Yes. 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 Okay. What is that should we find? Work done by what? Work done by the work done on the box. Work done is first times. But because you're talking about rough surface now and they mentioned kinetic friction, we won't just say first times this time. They didn't give us force, they gave us weight. Was it force they gave us? Was it force or weight? A 500 Newton box and that's weight, not force. You know. And I've already given you the formula for friction today. Who can remind me what friction? Please don't forget to mu mg times d. Who can remind us this mg? What does it represent? Weight. And that's what they gave you. Weight. Oh yeah, what's the mu? How much mu? 0.22. How much weight? 500. How much distance? 8 meters. Oh yeah, calculator. What do you get? 880. 880 Newton. 880. Let's go. Number 4. Number 4. Number 3, sorry. But don't call me. Calculate the coefficient of friction. Calculate the coefficient of friction between. Calculate the coefficient of friction between a wood. Between a wood. Between a wood of mass 2 kilogram. Between a wood of mass 2 kilogram and a horizontal surface. And a horizontal surface. And a horizontal surface. If the limiting friction, if the limiting frictional force, if the limiting frictional force is, if the limiting frictional force is 10 Newton, limiting frictional force is 10 Newton. So you can all do that. They give us force, we want to find mu. Are we given mass? Class, what's the formula for friction? Mu what? By now, you should have stuck to your brain now. Mu mg. And we they look for mu. So our mu now will be friction over mg. How much friction do we have? How many limiting friction now? 10 Newton. What's the mass? What's gravity? So the answer is 0.5, Abby. Can you see? Very simple. That's how your exam will be simple. How many of you will buy a special gift for me? Begin admission this year. Oh, God bless you. God, honor those hands. See, that's how some people raised hand last year. They don't come back. Oh. And again admission. They don't come back. So let's deceive her down. So yeah, I go back. They raise a leg and hand. I can't remind them for their matric. They say, not true. So don't be like those ones. So. Those ones are called covenant breakers. Next question, let's go. Number what? 4. The body in the diagram below, is about to slide. The body in the diagram below is about to slide. The body in the diagram below is about to slide. Calculate the coefficients. The body in the diagram below is about to slide. Calculate the coefficient of friction. Calculate the coefficient of friction. Calculate the coefficient of friction. They love this one every time you see it there. And the same thing in a draw. 25 kg, about to slide. Sketch it, and then they gave us 30 degrees. That's what they're always giving us in jam. Classwork, do it. I'm sure you know the answer, Abby. You have to raise your hand. Let me see. It should be true. They give you theta. What they find? What are we saying? They find mu, Abby. What's formula for mu? Tan theta. This one now yakpa question every year. So that be tan 30. What's tan 30? 0.57 or 1 over what? Root 3 or root 3 over 3 or 0. Anyhow they put down, just pick it. I move. Next question. Michael. Draw. M 20 Newton. 2 Newton. Right. The body in the figure above, experiences, the body in the figure above experiences a resistance force of 2 Newton. 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 Resistance force of 2 Newton. Full stop. Find the mass of the body. Find the mass of the body. Find the mass of the body. If it accelerates at 1.5 meters per second squared, find the mass of the body. If it accelerates at 1.5 meters per second squared, that one is very simple. The first thing is to find the resultant force. You know, this is a major force. This is resistance. That word resistance means what? Friction. So apply force minus friction will be MA. Apply force minus friction is MA. So the applied force now is 20. What's the frictional force? 2. Mass, we don't know. What's acceleration? 1.5, thank you. What's 20 minus 2? 18 is 1.5 mass. So our mass will now be 18 over what class? What do you get? 12 kg. Very easy. 12 kg. Right, let's go. Next question. Number what? Number, which of the following liquids is the most ideal for reducing friction? So the following liquid is the most ideal for reducing friction. So the following liquid is the most ideal for reducing friction. Option A, kerosene. Option A, kerosene. Option B, petrol. Petrol. Option C, grease. Grease. Option D, water. Class, scream the answer. What's the answer? Grease. Let's go. Number what now? Number 7. At terminal equilibrium, at terminal velocity, a body of weight, at terminal velocity, a body of weight 50 Newton, a body of weight 50 Newton, 50 Newton experiences, a body of weight 50 Newton experiences an upthrust, experience an upthrust of 30 Newton. Experience an upthrust of 30 Newton. Upthrust of 30 Newton. Come on. Find the viscous force between the layers of the fluid. Find the viscous force between the layers of the fluid. Find the viscous force between the layers of the fluid. Find the viscous force between the layers of the fluid. Classwork, do it. Go back and check formula I give you today. So, Mr. Dan, what do you know of terminal velocity? That's when you have equilibrium stage. Referring to equilibrium stage. Go to your note, go and check. I gave you, that's the last thing we wrote under friction before we started solving an example. Are we true? Very good. It's in your note. Check it. Oh, yeah. At terminal velocity, that means equilibrium stage. The weights. See, when your body is drawn, we already said that before. When the body is going down, in a liquid, or in air, or in a fluid, anyone, the body has 3 forces acting on it. Number 1, the weight. Then number 2, upthrust force. Then we have the viscous force. That's the frictional force in the liquid. As the body is running down, initially the weight will be higher than these two. But at terminal velocity, what does that mean? At velocity that is constant, terminal, end, like this terminal velocity stage, equilibrium stage. At that time, the weight will now be equal to the upward forces. So weight equals UV. How much weight then give us? 50. What's the upthrust? 30 plus V. So we have 50 minus 30 is V. So what's V now? 20 Newton. Very easy. Very easy. Very easy. Right, next question. Number what now? Number 7, 8. Right, the frictional force between the layers of a liquid, between the frictional force between the layers of a liquid is directly proportional to the radius. Is directly proportional to the radius. Directly proportional to the radius and velocity. Radius and velocity is a statement of radius and velocity. It's the statement of Option A, Archimedes. Archimedis. Archimedes. Option B, Pascal. Option A, Archimedes. Option B, Pascal. Option C, Stoke. 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 Option D, Bernoulli. Bernoulli. During A-level class, we taught all these things. Bernoulli. 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 Once your name ends like that, Li, you are from where? Italy. Bernoulli. So that was Syria, you see a lot of names like that. Viali. Oh yeah, what's the name, Clara? What's the answer to that question? Stokes Law. Stokes Law. There has not been any question on Stokes Law in your JAM, and it's in your syllabus. It's a law that states that the frictional force between layers of fluid is directly proportional to the radius of the fluid itself and then the velocity. That's what the guy said. AV. AV. We move. Next question. Number what? Number 9. The diagram below illustrates a body. The diagram below illustrates a body. Diagram below illustrates a body of mass 5 kilogram. Of mass 5 kilogram. Being pulled. Being pulled by a horizontal force F. Being pulled by a horizontal force F. Full stop. If the body accelerates, if the body accelerates at 2 meters per second squared, if the body accelerates at 2 meters per second squared and experiences a frictional force of 5 Newton, and experience a frictional force of 5 Newton, frictional force of 5 Newton, comma, find the coefficient of kinetic friction. 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 They didn't finish. Oh. And the value of F. And the value of F. This F. Let me even use it on to attempt to classwork, making a triumph. I won't talk. I won't guide you. G is 10 meters per second squared. How much mass they give us F? 5 kg. Oh, yeah, classwork. Yes. Are you true? What's the first question they say you find? Are we giving friction? Go and check. They give you friction. How much? 5 Newton. Who can remind what formula for friction? So everybody have forgotten. Mu mg na 5. So now have mu. What's mass? 5. Gravity equals what? 5 can cancel 5. 10 mu na 1. Mu. 1/10. What's the answer? So I'm not do am. So why? Because you are afraid. Afraid of nothing. Shadow. Then you find F. F minus friction and MA. Do you know this formula before? Force minus friction. So go look for F. Are we given friction? How much friction? 5. Are we given mass? How much mass? Acceleration 2. F minus 5. Now how much? Our F will now be 5 plus final answer. In the exam hall, you will not be stranded. As I always tell you, this exam time, don't do something that will push God away from you. You need more of God, more of mercy, more of anu. Don't go and start giving your receipt to somebody to enter class. And say, go and use it. Don't do things like that. Oh. We are raining prayer on you everywhere now. So those prayers should work for you by God's grace. Amen. Don't let your head deflect prayer. Jubilee students, some of you did not pay lesson fee last month. We got to know late. And you shouldn't do that. And some of you know about it, you will not talk. One is, all the students go out. Some of you will go and allow them to hide in the toilets. And you know them. You know them. So that's not good enough. Don't do things that will, make you lose blessing. HOH, don't be partaker of that. You must find out. OVAT is busy checking receipt and all. It may be busy. You guys can find out. Everybody submit your receipt and you are checking. That's part of your work. HOH for degree. Write the names of those who paid to mark it. Number 10 now. Last question on that. A ball falling. A ball falling through a viscous liquid. A ball falling through a viscous liquid. A ball falling through a viscous liquid is acted upon by a ball falling through a viscous liquid is acted upon by. If you miss this one, I will just beat you. Option A, upthrust only. Upthrust only. Upthrust only. Option B, upthrust and the ball's weight. Upthrust and the ball's weight. Upthrust and the ball's weight. Option C, the ball's weight and viscous force. The ball's weight and the viscous force. The ball's weight and the viscous force. Option D, upthrust, the ball's weight and viscous force. Option D, upthrust, the ball's weight and the viscous force. Upthrust, the ball's weight and the viscous force. Pick one answer. You have picked your answer. Let me see your answer. Let me see the answer of those that will gain admission. If you like, don't put your answer up. Or I've just done it, so I don't know why your answer is down. Cloud, what's the answer? D. Yeah, get ready to dance this year. Yeah, that's it. It must be a year of celebration for you. None of you have tried. Pay your due. Do more. Yeah, I'm going to topic number 8. I'll be 7. Simple machine. I'm just going small. Started with topic 1. We're going to simple machine. Topic 7, I think. Topic 8. Very good. So we will still get to that 31. Don't worry. We'll get there by God's grace. For a machine, MA, now load over what? Effort. What of velocity ratio? Effort distance over what? Load distance. Very easy. Then efficiency. Efficiency now waiting. MA over VR times what now? 100. Efficiency is also work output over what? Work input times 100. Work output. This one no, is not much over work inputs. But we don't want to take any chances. We're not going to leave any topic unturned. Times 100. That's efficiency. Then VR of some popular machine. VR, number one, incline plane. Incline plane. What velocity ratio for incline plane? 1 over sine theta. Then for pulley system, pulley. What velocity ratio for pulley? Number of pulleys, number of wheels, and block and tackle. Block. Okay, let me use wheel and axle. That will be better. Wheel and axle. Radius of what? Wheel over what? Just a bigger R over what now? Smaller R. Then let's add the screw jack. Now, guy, VR for screw jack. 2 pi A over what now? Pitch. Class, why is the efficiency of machine less than 100? Because of friction, majorly. And friction is the one that is making what? MA to be what? VR. And work output to be less than what? Work input. We have finished friction. Question 1. Go on, play. Does it right and right fast? A wheel and axle is used. Question 1. A wheel and axle is used. A wheel and axle is used to raise a load. A wheel and axle is used to raise a load of 2,000 Newton. A load of 2,000 Newton by the application of an effort. By the application of an effort. By the application of an effort of 800 Newton. Sorry, 80 Newton. By the application of an effort of 80 Newton. 80 Newton. Full stop. If the radii of the wheel and the axle, if the radii of the wheel and the axle, if the radii of the wheel and axle are 20 centimeter and 10 centimeter respectively, 20 centimeter and 10 centimeter respectively, comma, find the efficiency of the machine. Yeah, I saw one mistake in that question they gave us now. That 80 was actually 180, not 80. 180. Sorry. I know you can all do that, so everybody do it. Big R over small R. Have you now? For VR, then what's your MA? Load over. Oh yeah, quickly do it. MA. VR. What formula for VR? Big R over what? What's your big R? 20. What's your small R? Mr. Adam, you didn't convert. No need. So that's 2 Abi. Efficiency is what? MA over what? Times what now? Yeah, if it means that, never mind. It's error of question or error of cochlea. Your cochlea no pick something well. 1.11 over 2,000. What can get? 55.56%. Point 2. Point 2. Which of the following machine does not apply the lever principle? Which of the following machine does not apply the lever principle? Which of the following machines does not apply the lever principle? Lever, L-E-V-R. Does not apply the lever principle. Does not apply the lever principle. Option A. And so many people are waiting at the admin for a receipt. I have told you to do all this before today. So people have missed almost 3 topics. Apart from row 1, others, let's adjust for the late comer because they will soon come and start disturbing. If we don't adjust, no admission again, so adjust it. Oh yeah. Ground floor, do the same thing. So a late comer can stay at the back. There are many out there. I can see them on my camera here now. Move it. You are not moving. Yeah. The crowd here is enormous. Some of you are not moving. Okay. Move it so that your life can move forward. Ground floor, do the same thing. So when they come, they won't disturb us. Which of the following does not apply the lever principle? Thank you for obeying. God bless you. Option A, claw hammer. Claw hammer. Claw hammer. Option B, wheelbarrow. 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 Option C, single pulley. Single pulley. Single pulley. Option D, sugar tongue. T-O-N-G. Sugar tongue. Class, do you know the answer? Is claw hammer a lever system? What of wheelbarrow? What of sugar tongue? So the answer is what? Single pulley. What type of lever is wheelbarrow? First class, second class, or third class? In second class lever, what happened there? Load is between the fulcrum and the sugar tongue. What type of lever is that? Third class. What of claw hammer? First class lever, because the fulcrum is between the load and the effort. Please don't forget that. We move. Number 3. The efficiency of a machine is 70%. The efficiency of a machine is 70%. 70%. Calculate the work done. Calculate the work done using a machine. Calculate the work done using a machine. To raise a load. Calculate the work done using a machine. To raise a load. To raise a load. 10 kilograms. To raise a load, 10 kilograms. Through a vertical height of 2 meters. To raise a load, 10 kilograms. Through a vertical height of 2 meters. 10 kilograms through a vertical height of how many meters? 2 meters. Now we all know that efficiency is what? Work output over work input. Work output over work inputs. That's 100. That's efficiency. How much efficiency are we given? Check. 70%. Work output. That's load times what? Load distance. Output is your load. Input is your effort. Over work input. That's the one we are looking for. Times 100. So you have 70. What's the load we are given? How much load? How many newtons will be kilogram? 10 kilogram. That will be 100, Abby. Are we given load distance? How many meter? 2 meter. Don't forget to convert the load to Newton before you use it. Load to Newton before you use it. Then we have work input. That's 100. We're going to have 70 Wi equals 20,000, right? So work input will now be 20,000 all over 70. Calculator, what do you get? 285.7 joules. So efficiency is work output over work input times 100. Please, once you cite your teacher for, I think, English and maths in square, you student, let me know. I can stop. We'll continue later today by 1. Let's go. Next question. Last work. A machine, okay, K-square is here. So we stop here. Your normal classes resumes now. Then by 1, we'll be having some chemistry and also physics. So we'll be closing very late today because this is April already. We have agreed that in a month of April, so much work. We'll be apologizing on the Jubilee students. Sometimes your prep may be affected. But I won't want to start running after you with cane and say, go and do prep. And the same thing applies to the hostel. Even if we finish late, you still should find a way to read. In as much we won't say, go and read by 1 or 2 or 3 or 4, but you should read. Exam is here. So the engineering team, crew, please disconnect so that the engineering can have their mass.